finishing up section 6.1, we learn what it means to be a decimal. What does it mean to be a decimal? It just means a number that's based on 10. And our whole number system is based on 10. So the idea of a decimal describes all of the numbers we work with. Then what we're really talking about here actually is decimal fractions. Decimal fractions means the denominator is only a power of 10. So decimals are things like 7 is a decimal number. 326 is a decimal number. 2.37 is a decimal number. Now, as far as decimal fractions go, this number right here is a mixed fraction, a mixed number. But sometimes things are proper fractions, like 0.77. So that would be a proper decimal fraction. This would be a mixed decimal fraction, and all of them are decimals, but not all of them are fractions. We looked at converting decimals to fractions first. Anybody remember the trick there? How do I convert this to a fraction? So Monsi says it's 77 out of 100. How did you get that? How did you figure that out? That was the answer.
Place values.
Yeah, you just have to read the place value. This is the tens place, that's the hundreds place. So the proper way to read that is 7700. So the trick was to just read it properly. And don't use slang. Don't call it 0.77. Which means identify place value. Place value. Okay, so decimals to fractions. Now, I didn't really give the complete story here, so I'm going to leave a little space there and come back to it. So that's incomplete, it turns out. We spent the last part of the last class and the first part of this class converting fractions to decimals. How do we do that? How do we convert 1/4 into a decimal? We actually do the division. Yeah, the fraction bar means division, right? Take 1, divide by 4, right? So there's actually a process. Let 4 go into 1 and see what happens, right? And that's going to lead to the decimal 0.25, 2500ths. There's a comment in the chat I missed. So as far as moving a decimal, that's not really directly related to naming the decimal as a fraction. The real thing is identifying the place value, not moving the decimal point. Now fractions to decimals, right? Sometimes they come out nice. This one terminated. But they don't always. Like 1/7 means I gotta, oops, it's not 7. 1/7 means take 7 into 1, and whether I do it on a calculator or by hand, I have to find the pattern. And it turns out long division finds the pattern better than a calculator does. This one repeated. Back here, when we looked at turning decimals into fractions, I only looked at ones that terminated. What if somebody gives me a repeating one, like suppose somebody said, hey, 0.1111 forever, right? 0.1 with a bar over it. What fraction is that? What's the numerator and denominator there? We didn't go over that yet. So I want to spend a little time talking about that problem there. Now, you can trick some calculators into telling you that. So I'm going to try to do that. Some calculators have a fraction to decimal button and a decimal to fraction button. And so Desmos is one of those. Most Casio and TI calculators also do this. So if I had, a fraction like 1/3, or let's, clear 1 divided by 3, I hit enter and it says, hey, here's the decimal version, but it's got this little button here that says, hey, that's it as a fraction. What if I enter something like 0.11111 and I say, hey, what's that as a fraction? It's going to give me something like, oh, it just reads it properly. It's tens, hundreds, thousands, 10,000, 100,000. It says that's 11,111 divided by 100,000. This one doesn't go on forever, so I would have to give it enough ones, and then it starts to lose track. So if I put enough ones in there, eventually it says, I think it's 1/9. What? How do you know that's 1/9? So I'm going to show just a little algebraic trick there. So back to the notebook. How can I really show, besides messing with a calculator, that 0.1111, all those ones repeating, which could be more concisely written as a repeating 1 like that, how can I show that really is something like 1/9? And the problem is that this 1 goes on forever. And forever is a problem, because forever doesn't really exist. But 1/9 totally exists. It's just when I try to write it without the 9 in the denominator, because here, what is that? When I write something like 0.11111, that means I have 1/10, right? That's this one, and I have 1/100th, that's that one, and I have 1,000th, right? In expanded form, that's that one, 1,000th, there we go. And then this one here would be 1/10,000th. It's that one right there. And forever and ever and ever, right? Forever's trouble. So if I could get rid of the forever part, I'd be jamming. So here's the trick. This is a really cool trick. What I do is I say, okay, this has an answer. I'm going to call the answer x. X is some fraction that's equal to 0.111111 forever. Now, I don't like that forever part. So what I'm going to do is I'm going to get rid of part of that forever by multiplying by 10. And then of those infinitely many ones, I just put one of them on this side of the decimal point by doing that. Okay. Now, I'm going to change the order. I'm going to put the number x underneath. And what is x again? X is 0.111111. And what do these two numbers have in common? 10x and x. They're just two numbers. Well, they have in common this forever part. Their forevers are exactly the same, right? This forever decimal matches this forever decimal. And so what I'm going to do then, I'm just going to subtract that away. So we have this rule that says if two things are equal, we can subtract them and we'll still get equal results. So I'm going to subtract these two from each other. So on one side, I get 10x minus x is 9x. On the other side, subtracting decimals, we just have to line up the place value. 1 minus 0 is 1. What's 1 minus 1? Well, that's 0. What's 1 minus 1? Well, that's 0. What's 1 minus 1? Well, that's 0. What's going to happen forever over in this part now? What do I have for my decimal places? Anybody? What happens every time I subtract these place values? See, I get a bunch of zeros. Thank you. Okay, I get a bunch of zeros. Well, 1.0000 forever, that's just 1. So now I know that 9x equals 1. Solve for x by dividing by 9. Yeah, it looks like x is definitely 1/9. So I'm going to do that again on a slightly more complicated one. So what if I had 0.131313? Get the point? In other words, in this case, the 1 and the 3 repeat together. So that's my pattern. That repeating pattern is a problem, and I want to get rid of this forever here. Forever is trouble. Can't have that. So the last trick I had was to say, okay, let's let this equal x. And I took 10 times x. And the reason I did that is taking 10 times x gave me a whole number here, but it lined up these decimal places for subtraction to give me zeros. Now, don't write this down, but if I try to multiply by 10 here, what does 10x look like? Well, that's just going to shift the decimal point once. That's going to be 1.3131, and then dot, dot, dot forever. The question is, do these guys match? And the answer is no. Darn it, they don't match. So I'm just going to get a little more clever. 10x didn't work. I'm going to try 100x. That's going to move the decimal point 2 times, and that's going to be 13.131313 forever. The original number x is 0.131313, and now these places line up, and I'm ready to subtract. So in the previous problem, I had to multiply by 10 because only one place repeated. Here I had to multiply by 100 because 2 places repeated. What do you think I would do if 3 places repeated? Multiply by 1,000. Nailed it, Abilene. Yeah. So we just look at how many places are repeating, and we multiply by a 1 with that many zeros, 10, 100, 1,000, and so on. So when I subtract here, 100 minus x is 99, 100x's minus 1x is 99x's. Over here, 13 minus 0 is 13, and then all of this subtracts away, right? 1/10 minus 1/10 is no tenths. 300ths minus 300ths is no hundredths. 1,000th minus 1,000th is no thousandths. 3 10,000ths minus 3 10,000ths is no 10,000ths. They're all gone, yay! And so x here has to be 13 over 99, and I can check on the calculator to see if that actually works. 13 over 99, it worked. 999 in the denominator is wicked cool. Check this out. If I take 1, 2, 3, and I divide that by 999, look at the repeating pattern there. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So I'm going to have you guys make a guess at what's going to happen here. Suppose I had the decimal 0.456 repeating. Can you guess at what fraction that is based on the pattern of 9s we just observed? What's the numerator and what's the denominator here? No guesses. Hopefully you're checking on your calculator. I get too excited and do that too fast. Sometimes I get all too excited about this stuff. Oh, we got a suggestion. The suggestion is it is 456 over 999, and that is correct if we plug that into a calculator to check it out. 456 over 999, 0.456, and it just keeps on going. This one reduces, and I can tell because, let's see, 4 plus 5 is 9, plus 6 is 15. 9 plus 9 plus 9 is 27. 3 goes into 15 and 27, so 3 goes in the top and bottom here. So this will reduce a little bit, dividing top and bottom by 3, as Desmos tells me. Isn't that cute? I love this fraction of decimal buttons. All kinds of fun stuff. All right, so there's a couple points with what we're doing here. One is I'm just trying to exercise your brains and question what we thought we knew about math. And two is that mathematics is an exploration. You got to play with it to try and figure stuff out. And just being told stuff isn't sufficient. So we want to try and throw these explorations in and get used to being wrong, because that's life. We're wrong most of the time. And we shouldn't expect in a math class that we're supposed to be right most of the time. It's just not true, because we're learning new stuff. Okay, I think now I'm done with section 6.1. All right, moving along.